Hello, hi, and welcome back to my channel. In today's video, we are going to learn about Dagger Hilt and how we can use it in our Android application. But before diving straight into Dagger Hilt, there are a few things that we need to understand beforehand. So there is something called dependency injection. This is a technique that is widely used throughout the programming, and it is well suited in Android development. So we need to understand this first in order to understand what is Hilt and why we should use that. Okay, so first of all, what is dependency injection and why we need it? So to get a better understanding of it, we should take an example. So I will take this example provided by the Google documentation. So let's say you are creating a class called car, okay, like this, and you're creating an engine inside the car class, and then you're using that engine in your car class. Now the problem here is that the engine is tightly coupled to the car. Okay, so that means that the engine is getting created inside the car class. Let's say moving further in your project, you want to pass a different type of engine. It can be an electric engine, it can be a different type of engine that you want to pass. There is some subclass of engine that you want to use it in your car. In that case, you won't be able to use it because the engine and car are tightly coupled with each other. Engine is getting created inside the car itself, and there is no possible way to pass the type of engine you want to this particular car. Okay, this makes the car class less reusable and a bit difficult to test, and also it provides some issues while refactoring when the code increases. Okay, so in order to fix this, what we need to do is we need to make both of these loosely coupled. We need to make the engine, or I mean we need to make the car dependent on the engine. So we need to provide the engine to the car and not make the engine inside the car. Okay, so right now what is happening, engine is created inside the car. Okay, but we don't want it because moving further there are possibilities that we might want to have different types of engine. Okay, this can be anything, any example you can take. You can see a lot of real life application scenarios where this works, where there are a lot of things that you want to reuse, and if you write this sort of code where two things are tightly coupled to each other, then you won't be able to reuse it. Okay, so what we have to do here is we have to make the car dependent on the engine by providing the engine to the car. So what we need to do here is we need to provide the engine to the car, and we can do this by passing the engine in the constructor. What we can do here is we can create an engine separately and we can pass it in the car class, and the car can then use it. So instead of creating the engine inside the car, we can create the engine separately. It can be of any type, and then we can simply pass the engine to the car class. Now, what benefits this particular approach here is that you can reuse the car class completely. You can pass different engines and then you can reuse the car instead of making it tightly coupled and not passing or not having the option to pass a different type of engine. Here you have the option to pass a different type of engine. Also, it helps in the testing of this particular class. So what happens here is, let's say you want to create a fake engine with a lot of different configurations. You can create, let's say, fake engine, multiple fake engines, and you want to configure it separately or differently according to your use cases. You can do so here. Since these two are not tightly coupled, you can configure the engine according to you and you can pass it simply to the car class. So that is how you can see here that separating and making it loosely coupled helps in the betterment of your code. Now this what we have done here is manual dependency injection. What we have done here is we are making the car dependent on engine and we are injecting the dependency through the constructor. To repeat it once more, we are making the car dependent on the engine and we are providing the engine by injecting the engine to the constructor of the car. While we are creating the car class, we are injecting the dependency to the car in the constructor. Now, manual dependency can be of two types. I mean, manual dependency injection can be of two types, where you can either provide it in the constructor or you can do something called field injection. So instead of passing it in the constructor, what we can do is we can create a late init var and we can update that particular field by providing the the value to it at the time of implementation. So here you can see we are not passing the engine in the constructor itself. We are just creating it as a late init var field, and we are updating it, when we are creating the car. That's it. So there are two general approaches. One is the constructor injection and one is field injection. You can use it accordingly to your needs, but these are the two methods that is widely used for doing manual dependency injection. So to reiterate once more, what is dependency injection is that what we are doing here. So we are making the car dependent on engine, and we are injecting the engine to the car class. That's it. And we are doing this manually. We are writing the code for it. We are creating the engine object. We are passing it manually to the car constructor. That's it. There is an alternate to dependency injection also. There is something called service locator, which can be also used depending upon your project and your application. So what this basically does is that you create a class known as service locator, and that creates and stores dependencies and then provides those dependencies on demand. Basically, you create something like this, an object called service locator, and it has a lot of functions. It can be get engine, get electric engine, get petrol, get diesel. You can create n number of functions which would return back the dependencies. For example, the car requires engine. So you have created a function called get engine, which is just simply returning back an engine object. And in the car, then what we can do here is we can just call service locator.get engine, and it will give me back the engine object. Okay. Now the basic or the most important difference between service locator and dependency injection is this, that with service locator pattern, classes have control and ask for objects to be injected, whereas with dependency injection, the app has control and it injects the required objects. Okay, so if you remember over here in the manual dependency, what we were doing was the main app was providing the object to the class, whereas in service locator, the class was asking for the object like this, and then it was getting consumed. So that is the main difference between the service locator and manual dependency. Manual dependency is widely used, so there are a lot of libraries that we can use instead of doing manual dependency injection, because as the code progresses and there are a lot of dependencies that piles up, it is very difficult to manually maintain it. Therefore, a lot of libraries and frameworks are used for doing this. So there is a library called Hilt, which is built on top of Dagger. So let's check that out. There is something called Hilt, which is built on top of Dagger. So Dagger was a library, or it is a library, but it is a very tedious to configure it. So what they did was they added a layer on top of it, and which is called Hilt, and underlying it is still using Dagger. So Hilt provides us with a lot of easier methods to do the dependency injection instead of manually doing it. Instead of manually creating the object and passing it, we can use certain annotations provided by Hilt to do the dependency injection. And we will see how this works by seeing a real life example. So we are going to use the previous project that I created, which was Work Manager. So we are going to use that code, and we can see how we can remove the dependencies, the manual dependencies inside it by using Hilt. Okay, let's get straight into the code and see how Hilt works. So we are going to use the previous project that we worked on, which was Work Manager, and we are going to see how we can replace the manual dependency injection that we did with the automated one by using Hilt. So we created view model that required worker factory, and then the worker factory required the worker repository. So you can see that the worker factory needed worker repository, and then the worker repository was needed by worker view model. So we can make it a bit cleaner. We can remove the factory altogether, and we can make the use of Hilt, where the view model will directly be injected by the instance of worker repository. Okay, and we don't need to manually inject it every time when we are using it. So first of all, what we need to do here is we need to add the dependencies for Hilt. So let's do that first. Open the project level app Gradle file, and let me grab this quickly. We need to add this dependency over here, the class path. I will provide the entire code in the description below. Feel free to check it out. After this, open the app level Gradle file. We need to add plugins, Kotlin capped and Dagger Hilt Android plugin, and then we need to add the dependencies for Dagger Hilt. Okay, now once this is done, we'll click on sync now, and it should sync it. It should install all the dependencies. Then we'll go back. We will create a few files. Okay, so inside this package, we are going to create a file called work manager application, which would extend the application class. So what is required here is that if you know the basics of Android, that the application class or the class that you are extending it with as application will be called first whenever your app is opened. Whenever your app is started, application class will be called first. So this is the class that we have extended with application. This will be called first, and what we need to do here is we need to say Hilt Android app. Okay, this is how the Android understands, your project understands that this is a Hilt based Android application. Then in the manifest, we need to provide this particular application class. You can see it automatically detects that this is a certain class which is extending the application class, and we're going to use it over here. Okay, now once this is done, it basically means that our application is going to use Hilt. Now we will go to the activity, and we need to add one more annotation over here, which is Android entry point. Okay, now what does this mean is that this tells Hilt that this is the entry point of an activity. Okay, so Hilt needs to understand that this is something that comes under the Hilt. This is the activity which is going to use Hilt. Similarly, you can use fragments and you can use Hilt over there also. There are a lot of different annotations that you need to go through for all these different cases. I will provide all these things in the description. I will provide the blogs and the documentation about all these different types in the description. But now, once you've added this, it basically tells that the main activity is an entry point of the Hilt Android activity. Okay. Now we are going to create another file called worker module. So let's first of all create it, and let's see what we are going to use this file for. So we are going to call this as worker module, and it is going to be an object class. Let's add this. Now what this file will do is this file will provide all the dependencies that will be required by the other classes. For example, view model requires the repository, right? So this is the module that will provide that dependency. So what we are going to do here is we are going to first of all annotate it with module, and we are going to add the scope to it. So what this essentially does is, let me first write it. So what this essentially does is that we are adding the scope to this particular module. So which means that whatever we write inside this particular annotation, inside install in, that is the scope of this module. For example, singleton component is the topmost hierarchy in the hierarchy of the scopes. So I will provide you the link where you can find the different hierarchy, the entire hierarchy of these scopes. So there is activity level scope, there is, let's say, view model level scope. You can accordingly add that particular scope to your module. So what will happen, only the classes which are under that particular scope will be able to get those dependencies. Okay, after this what we will do is we will simply create a function called, let's say, repository. The function name doesn't matter, and it will be returning the iWorker repository. and we are going to add the singleton annotation here as well as provides. Okay, and this will, what this will do is this will simply return worker repository. Now what we need to do here is that we need to somehow use the context inside worker repository. Okay, so there are different ways to approach this. You can actually pass the context, or you can directly, so there are multiple ways to do this. So worker repository here requires context, right? So we can provide that context in multiple ways, but the simplest way to do that is we can just pass the context inside the view model itself. Okay, so how we were doing it earlier was, we can go to that particular line. So we were passing factory inside the worker view model, right? And this worker view model was accessing the worker repository. So this is going to be essentially the same thing. Instead of passing the factory here, we are going to access this dependency here itself. One more take. So as you can see here that the worker repository requires context, right? So we need to provide the worker repository the context. You can do this in multiple ways, but since we want to provide the context of the activity itself, what we can do here is we have to somehow pass the context via worker view model to this particular function. Earlier what we were doing was we were passing it inside the worker repository itself as a parameter, but what we can do here is we can, instead of passing it in the context, we can remove this, put it inside here, remove the private, and we can also add one more parameter to the compress file and update the interface also. Now see, it is fine over here as well as it is fine over here, because we don't need to pass the context here directly. But what we need to do is that we need to pass the context via the worker view model, right? So here now it will ask for context, and we are going to pass that context to the particular function. Okay, now as you can see, we are injecting the dependency over here, right? We're injecting the worker repository dependency over here, but this particular file is not using the dependency that we have created as of now. So we need to do that. We need to add those lines to this so that it starts using it. So let's do that. So inside the worker view model, what we have to write here is, first of all, we have to annotate it with Hilt view model. Then we have to write inject constructor. That's it. Now what this will do here is that it will first of all identify the worker view model as a Hilt view model, and this will automatically inject the worker repository that we have mentioned here. That will happen out of the box. So since we have already mentioned the scope of this module, and since we are already telling that whatever we are adding inside this particular module should be used everywhere where that particular function or that particular dependency is required. So what essentially we require here is the worker repository, and from where we can get this, from this get repository function, as we have annotated it with provides. Now what we can do is, to modify it more, we can simply remove this entire thing, this entire worker factory. But first of all, let's store the context in a variable called context. Remove this entire thing, that is not needed anymore, and we can simply write Hilt view model, and inside the compress image we can simply pass the context. That's it. So now what will happen here is that as soon as the worker view model is created, as soon as it goes here, it will look for this dependency. or it will look for a module which can provide this dependency. So since we have given the scope of this module to be the singleton component, it will come here and it will see that there is a function which provides this, and it will access this function to get the dependency. And finally, that will be injected here, and we can simply use this inside the function. Now, when we run the application, there shouldn't be any change. It should run smoothly. Now let's see if it works fine or not. So what should happen here is that it should work exactly the same as it worked in the previous project. So it's when I click on this particular card, it should ask me to upload an image. And once that is done, if I click on the compress button, it should compress the image and save it in the local database. But earlier we were adding few dependencies manually. We were adding the worker factory, we were using that worker factory and then adding it to the view model, and then the view model was accessing the worker repository from the factory and then was calling the function. And we have removed all those things by simply adding Hilt to our project, where we are using the constructor level injection to add the worker repository automatically, which is provided by the worker module as it is scoped to the singleton component type. Okay, so let's see if it works fine or not. We click on the upload image, it opens the gallery, we select the image. Let me select the image. It displays the image. If I click on compress, now it should show two notifications, one for compressing and then for the saving of the image. So you can see two notifications popped up very quickly. Now to check if it worked fine or not, let's go to the files, open up the local storage, go to Android, go to data, choose our application, go to files, and we can see this is the compressed image that we have just created. It is 878 just now, but yeah, this is the exact compressed image that was created. So everything is working as it is. But what we have done here is we have converted our non-Hilt project to a Hilt project by simply adding like few files and few annotations here and there. So that's pretty much it for this particular project, for this particular video. If you find this useful, please share this video to your friends and do like the video if you stay till the end, and do subscribe to my channel. We'll see you in the next one. Thank you.